In this video, you will be introduced to probability.
An experiment is a process that, when performed, results in one and only one of many observations. Outcomes are observations from an experiment. Sample space is the collection of all possible outcomes of an experiment. An event is a collection of one of the outcomes of an experiment. Event can also be defined as the subset of a sample space.
Example 1. Experiment is: toss a balance coin. Outcomes is either a head is observed, or a tail is observed. Sample space: S equals to HT. N of S is equals to 2. Event: set A equals to H. N of A is equals to 1. Set B equals to T. N of B is equals to 1.
Example 2. Experiment is: throw a dice once. Outcomes is either 1, 2, 3, 4, 5, 6. Sample space: S equals to 1, 2, 3, 4, 5, and 6. N of S is equals to 6.
Some examples of events are as follows. Set A is the event that a 5 is observed. Then set A consists of the element 5. N of A is 1.
Set B is the event of observing a number of less than 2 or greater than 5. Set B consists the elements 1 and 6. N of B is 2.
Set C is an event of observing odd numbers. Set C consists of the elements 1, 3, and 5. N of C is 3.
Example 3. There are 52 cards in a standard deck. The cards are shuffled. A card is taken out. The possible outcomes are: the sample space S is N of S is 52.
Suppose event A is an event that a jack is observed. Then A consists of jack of spade, jack of diamond, jack of heart, and jack of club. N of A is 4.
Another example. Event B is a heart is observed. Then B consists of ace of heart all the way up to king of heart. N of B is 13.
Event C is an event that a king of heart is observed. Set C consists of king of heart. N of C is equals to 1.
Example 4. The experiment is: a red die and a green die are thrown simultaneously. All possible outcomes are pairs of values represented by the dots shown on the chart.
The sample space are pairs of 1, 1, 1, 2, 1, 3, all the way up to 6, 6. N of S is 36.
Let A be the event that a 1 and a 6 is observed. Then set A is pairs of 1, 6, and 6, 1, and N of A is 2.
Let B be the event that both faces show a 4. Then set B consists pairs of 4, 4, and N of B is 1.
When an experiment is performed, we do not know what the outcome will be. Therefore, the event or the outcome of an experiment is random. So how do we measure the random event?
The random event of an experiment is measured by using the concept of probability.
By definition, probability is a numerical measure of the likelihood that a specific event will occur.
If the probability of an event is 0, then the event will never occur. If the probability of an event is exactly 1, then the event will definitely occur.
The closer the probability value is to 1, the more likely that the event will occur. The closer the value is to 0, the less likely that the event will occur.
To calculate the probability of an event for an experiment, you need to have the number of outcomes for that event, and the number of all possible outcomes for the experiment.
Suppose you want to calculate the probability of event A. You need to know N of A and N of S.
Probability of event A is denoted by P of A. And the probability of event A is P of A equals to N of A divided by N of S.
The value of probability of an event can be expressed in terms of 1, fraction, 2, decimal, 3, percentage.
Example 1. Toss a balance coin. A is an event that a head is observed. N of A is 1. N of S is 2. The probability that a head is observed. P of A is 1 over 2.
B is an event that a tail is observed. N of B is 1. N of S is 2. The probability that a tail is observed. P of B is 1 over 2.
Example 2. Throw a dice once. A is the event that a 5 is observed. N of A is equals to 1. N of S is 6. Probability that a 5 is observed is. P of A is 1 over 6.
Next example. B is the event of observing a number less than 2 or greater than 5. N of B is equals to 2. N of S is 6. Probability of observing a number less than 2 or greater than 5. P of B is 2 over 6.
Next. C is an event of observing an odd number. N of C is equals to 3. N of S is 6. Probability of observing an odd number is. P of C is 3 over 6.
Example 3. A deck of cards is shuffled and a card is taken out. A is an event that a jack is observed. N of A is 4. Probability that a jack is observed is. P of A is equals to 4 over 52.
B is an event that a heart is observed. N of B is 13. The probability that a heart is observed is. P of B equals to 13 over 52.
C is an event that a king of heart is observed. N of C is 1. The probability that a king of heart is observed is. P of C equals to 1 over 52.
Example 4. A red die and a green die are thrown simultaneously. A is an event that a 1 and a 6 is observed. N of A is 2. Probability that a 1 and a 6 is observed is. P of A equals to 2 over 36.
B is an event that both faces show a 4. N of B is 1. Probability that both faces show a 4 is. P of B is 1 over 36. Thank you for watching.